Okay, in this video, we're going to explore how to find the various key points on a parabola written in standard form, then how to use that information to both write the equation in vertex or graphing form and then graph the parabola. Okay, so let's start off by finding the intercepts and the vertex first. So let's start out with the y-intercept. So in a standard form equation, the y-intercept occurs at the c value. So in this case, the c value is the constant or the last number in the equation, 12. So the y-intercept is going to be at the point 0, comma 12. Okay. Let me fix that. I don't like that. There you go. Now, normally I would plot the point, but it's not on here. I guess we could try to sketch what we think it might be. So y-intercept is going to be somewhere up here. Okay. Not exactly sure where, but it'll be up there somewhere. Okay, now let's find the x-intercepts, or the x-intercepts. We don't know how many there are, so I just put it in parentheses. So to find the x-intercepts of a parabola, we need to set the y equal to 0. So we're going to set this equation equal to 0. Now we do have two ways of solving standard form equations when they're set equal to 0. We can use the quadratic formula, or we can factor it. So in this case, since there's no a value or no leading coefficient on the x squared, we're going to see if this factors by playing a number game in our head. So we want to determine, are there two numbers that multiply to equal the last number, which is the 12, and at the same time add equal -8, which is the middle number. So multiply to equal the last, add equal the middle. In this case, there are, so that would be -6 and -2. So we can factor it as into two different factors, where x minus 6 is one factor and x minus 2 is the other. And then we solve that equation using the zero product property. So we determine what values of x make each factor equal 0. So we can clearly see for the second factor, x minus 2, when x is 2, well, that factor will be 0. And then for the first factor, x minus 6, when x is 6, that will make the equation 0. So those are the values, therefore, those are our intercepts. We're going to write them in coordinate form. I'm going to plot them. So 2 zeros here, 6 zeros here. Oh, my 12 went away. Okay. So here we go. So I got the x-intercepts found, the y-intercept found. Now we're going to find the vertex, but we're going to do two things at once. We're not only going to find the vertex, but we're going to write the equation in vertex form at the same time. So I like to, when a is 1 in my equation, I like to use an area model to find the vertex form. So I'm going to make a 2 by 2 box. So to complete the square with this, we're going to take x squared and put it in the top left-hand corner of our rectangle or square. We're going to fill in this left to right diagonal going upward by taking the middle term, dividing it by 2, which gives us -4x. And we put those in the top right and the bottom left-hand box. Because remember, that diagonal always adds equal the x term or the middle term. So see, we got our x squared, which is in our equation. We got our -8x's, which is good. So we're going to use that to kind of factor out the edges or the height and base of the square. So let's start with this column of x squared and -4x. So what is the GCF of x squared and -4x? Well, we don't care about the negative because they're not both negative. So 4 and 1, biggest number divided into those evenly is 1. They both share an x, so the GCF is x. Then once we have that, we can fill out the rest of the edges. So to fill out this edge to the left of x squared, we ask ourselves, x times what gives you x squared? Well, that gives you an x. Then to fill in the edge by the -4x, we ask, x times what gives you -4x? Well, that's -4. You can clearly see that's the same thing up here. So our graphing form or vertex form is the equation so far y equals, the a value is 1, It's going to be x minus 4 times x minus 4, x minus 4 squared. Because that's what this box relates. And then I'm going to complete the square. So we're going to figure out what the bottom right-hand corner is. So negative 4 times negative 4 is 16. Here's the deal. I don't want 16. I want the original c value of 12. So it looks like I have too much stuff. Ultimately, when I multiply out this vertex or graphing form, I want it to equal what I started with. So we have the 16 down here. We have too much stuff, so we got to take away something from there to get my 12, and that is a 4. And so we're going to subtract 4 from the end, and that gives me my k value. So here's my graphing form or vertex form equation. So that means the vertex has to be the point h. So h always lies, so we take the opposite of it, positive 4, comma, k is always what I want it to be, negative 4. So I'm going to plot that point. 4, 1, 2, 3, negative 4. So now that I have the vertex, I know the x-intercepts, so I can take the y-intercept and actually reflect it. So the y-intercept is 1, 2, 3, 4 units from the line of symmetry. That's the vertical line that goes through the vertex and splits the graph into two symmetrical pieces. So if the y-intercept is 4 on one side, then there has to be another point, 1, 2, 3, 4 on the left. Then I got 5 points. This is really okay. That's good enough to draw a parabola. Now I could find more points, so I could put in like 3 in there and see what I get, or 1. I could kind of calculate those, but I don't have to. But I'm going to, connect the dots. I curve through the parabola's vertex, go up, and then that is my parabola. Now there are other ways to find the vertex, which I'm well aware of, but normally when I want to go to vertex form, we're going to use completing the square in most cases to find that, so it's easier to hit that out with the vertex. All right, so hopefully this is helpful in your exploration of parabolas and completing the square and graphing quadratic equations. So if you liked what you saw, like this video, subscribe to my channel, and I will see you next time.